In this question, it is important to draw a perfect figure, a correct figure. Now here, a kite is drawn inside a regular hexagon where the vertices of the kites are the midpoints of the four sides of the regular hexagon. Okay. So first of all, I'll draw a rough regular hexagon. Now, after drawing this regular hexagon, we will select the vertices of the kite. So one of the vertex of the kite will be the midpoint of this side. The other two will be the midpoints of the adjacent sides, and the last vertex will be here. So joining these vertices, joining these midpoints of the four sides of the regular hexagon, we can draw a kite like this. Okay, right? So now we'll have to find out the area of the kite and we'll subtract it from the area of regular hexagon. Okay, now area of kite is half the product of the two diagonals. Okay, and the area of regular hexagon can be easily written as 6 times root 3 upon 4 side square. Root 3 upon 4 is the area of one of the triangles, one of the equilateral triangles, and regular hexagon is made up of 6 equilateral triangles. So we'll be finding these two areas using the formulas that I have written, and then we'll take the difference of these two, and that will be the final answer. Okay, so first of all, we'll calculate the length of both the diagonals of this kite. So this is the figure that you can see. Okay. Now here, first of all, I'll calculate the length of SQ. SQ will be the shorter diagonal of this kite. Now, since S and Q are the midpoints of AF and BC, S and Q are the midpoints of the respective sides. Okay, and considering this figure ABCF. Now, what is this ABCF? ABCF, AB and CF are parallel. So this is a trapezium where AF and BC are equal. So basically, this is an isosceles trapezium, right? Now, in any trapezium, a line joining the midpoints of the non-parallel sides is called the median, and the length of this side will be, so SQ will be equal to half the sum of the parallel sides, that is AB plus FC. All right. Now AB we already know, it is 3 root 3. Now FC is the longer diagonal of this hexagon. For a regular hexagon, the length of the longer diagonal is twice the side. So FC will be equal to 6 under root 3. So the value of SQ, that is the shorter diagonal of the kite, will be equal to 9 upon 2 under root 3. Okay, now this is SQ. Now let's look at the length of PR. Okay, now PR is basically double of PO. Okay, so to find out the length of PO, I'll draw a line parallel here and we'll join this. So let's say this point is R. Okay, no, R is already there. So I'll call it as X. So this point as X. Done. Now I need to find out the length of AX in the triangle AXF, where this angle is 60 degrees. Angle F is 60 degrees and AF का length पता है 3 under root 3. We already know the length of AF, that is 3 root 3. Okay, so the length of AX, how to find out? You can consider sine of 60 degrees, which is root 3 upon 2, right? So sine of 60 degrees, which is root 3 upon 2, and AX will be equal to root 3 upon 2 multiplied by 3 root 3, and that is equal to 9 upon 2. Now PR, that is the longer diagonal of the kite, will be equal to twice of AX. So twice of 9 upon 2, that is equal to 9. So now we have obtained the length of both the diagonals of the kite. So area of kite is half d1 d2, okay, and that is equal to half multiplied by 9 upon 2 root 3 multiplied by 9, and that is equal to 81 upon 4 root 3. So this is the area of kite. Now area of hexagon, regular hexagon, is 6 root 3 upon 4. I can write it as the 3 root 3 upon 2 multiplied by side square, that is 3 root 3 whole square. So this is 27 into 3, 81. 81 upon 2 under root 3. Now taking the difference of these two numbers, so 81 upon 2 root 3 minus 81 upon 4 root 3 will be equal to 81 upon 4 root 3. Okay, so 81 upon 4 root 3, option B will be the correct answer for this question. Right, so that was question number 13. Let's move on to question number 14.